I want to talk about the direction of the net impulse applied to an object. All right. And it's essentially vector addition, but we need to be very good with these, okay? So it says that some initial and final momentum of an object is shown. So what if we have some sort of initial momentum going up? So this is P initial, okay, and this is a vector. And we have P final going this way. What would be the change? What would be the net impulse? Well, the net impulse is a fancy word of saying the change in momentum. What is the change in momentum? And we know the change in momentum is defined as P final minus P initial. Okay. So remember how we do this. Take P final. Okay. P final will stay the same. Okay. P initial. Yeah. P final minus P initial. Remember we said that we could take P initial, take the opposite of it. So it's going in this direction is positive. If it's in the opposite direction, it's negative. Okay. So that would be minus P initial, and we just stick the tail at the tip of P final. So therefore, taking a negative direction of P initial, this would be negative P initial. And then we said the net impulse or the change in momentum is from tip to the tail. So therefore the new direction would be so this would be a change in momentum, or P final. So that would be the new direction. Okay. Let's look at another one. What if we had some sort of final momentum? P final going this way. And we had P initial. So this is P initial going that way. What would be the net impulse applied to the object? Well, again, we just said the net impulse or the change in momentum is equal to P final minus P initial. So if that is true, then I take P final just like it is. This is P final. I'm going to take the negative of P initial and stick the tail at the tip of P final. So if I take the negative initial, negative P final, then I just flip the direction. So now taking the tip, it'll be going this way. It'd be going this way with approximately the same magnitude. Okay, approximately the same magnitude. Okay, and so if I'm looking at this, a new direction is from the tail of P final to the tip of negative P initial. This is negative P initial, and so you could see the vector is just going straight across to the right. Instead of a change in momentum or the net impulse applied to the object. Okay, so let's look at another one. What if we had P final going this way, and we had P initial going that way? What is the net impulse applied to the object? Well, I take P final just like it is. Oh yeah, this would not, I'm drawing this too close. So I take P final like it is. This is P final. And I take the negative of P initial and stick it at the tip. Okay, so P initial is going down. I'm going to flip it the opposite direction. That will give me negative P initial. So I just put the tip at the tail of P final. So this is negative P initial. And then the new vector goes from the tip of P final to the tail of P final to the tip of P initial. And there's our new vector, and this would be the change in momentum. Sorry guys, my vector struggle. All right, let's look at the last one. All right, so again, we have some sort of P final. So maybe we could say this is, this is P initial, and then we have some sort of P final going this way. What would be the net impulse applied to the object or the change in momentum? Okay, well, again, we take P final just like it is. We don't change anything about P final. We take the negative direction of P initial and stick the tail at the tip of P final. So therefore it looks something like this. So this would be negative P initial. And new vector is from tail to tip. Yeah, new vectors from tail to tip, so it goes straight up. So this would be the change in momentum, or the net impulse applied to the object in that direction.